so happy because my student help me always, anytime. Okay, entonces function and relation. Okay, let me start from relation. Relation is, see, I find in the book the definition is a set of, is the set, is the set, is the set of order pair, of order pair, order pairs. Ajá, es la que x, y, ¿no? Pero no, I don't understand very well. What relation is connection, association between two sets. Suppose. One example to understand very well relation. It's extremely easy. Suppose I have my one, no this class, because this class have 38 students. Suppose a small, super small class, theoretical, a small class, que es students in MAC1105 college algebra class. Maybe in 2025, future. Entonces, we have 4 students only. And the students are Sally, Paul, King, Luis. 4 students only. There are no difference, I listing more. No, this is the same idea. And this is the first set. We are talking about set. Set is a collection of the objects separated by comma. First set. And normally the first set is called domain. Okay, in one relation, domain. This is a technical name. Normally it's called domain. Let me put this word because it's important. Domain. However, I have another set. It's the set of the overall grade in college algebra. Suppose overall grade when the class is over, when the course is over in December something, the overall grade I need to assign my student is when we have different possibilities, you know, A, I suppose that the majority of you get A, B, C, D, by the way, D, you don't pass, I need to repeat again, and F, is completely a mess, no? Pero no, nobody get F. Only the student can don't do the assignment, entonces maybe get D. Entonces now, this is the second set, que es called normally range. Okay, range is the second, and domain is the first. Now, this is a moment to represent relation. Relation is the association. I associate, for example, relation. Let me copy here, relation. Relation is the association, for example, I know que Sally, that you open parentheses like order pair, like that, bam, and you copy first component, and second component. And the first component belong always to the domain. Entonces, Sally, suppose que es excellent student, I put Sally, A. And this order pair represent the association in one element, one person, one student, in the set domain with the one grade. Let's say Paul, Paul. There are different comma que separate each order pair. Es Paul B, because Paul maybe don't do the homework. No extra credit. And fail one question on the test, or 2 questions. And King, no, King is B again, okay. And finally Luis, G. Okay. So this is a symbolic way to represent relation. Is the set of the order pair. Order pair means one or mathematical object que contain first component, comma, y component. Okay, that's it. Relation. Now the relation you are doing in our life in every day. For example, when you ask for something, what is the price of these shoes? Entonces yo try to associate the shoes, que es the object, and its price, que es a number, $15 or $45, I don't know. Okay, entonces normally in the real life we are doing always association. Entonces es relatively easy to understand relation. However, what about function? Say again. I don't hear. Say again. Repeat again the question. No? Okay. Okay. Function. Function, well, function is special. To understand the function is, well, function actually is a relation. But special relation. A special relation. What is the consideration in the function? Such that each value in domain, remember domain is the name of the first set que you declaré, so it's completely, so two set, you have two set, pero it's important the order, domain onto the range. Entonces it's totally, you need to declare what set is domain and another set is no domain, is a range. Entonces es in the domain is associate SS associated with, and this is the most important word in the definition, or two words, only one value in the range. Entonces this is, at least for me, this is definition, formal definition, blah, 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 blah. But at least for me, it's not too clear, this information. Let me try to explain using example. Suppose now, okay, we have domain. Okay, I want to call, because frequently in mathematical equation, you call X. Capital X is domain. And the domain is 1, 2, 3, 4. 4 number. And capital Y is the range. In this case, not necessarily a number, it's a letter A, B, C, D. Okay? Entonces I want to write, after that, one by one, relation 1, relation 2, and relation 3, I want to investigate, according to the definition, if this relation is a function or not. So relation 1, R, capital R1, is, remember, is the set of the order pair, in this case 1, A, you associate like an order pair, one element in the domain, que es this. I declare a domain and range this. So 1 associated with the A, comma, 2 associated with the B, comma, 3 associated with the C, comma, 4 associated with the D. And so I come back to the definition, and the definition say each value in the domain, this, and this, is associated with only one. So 1 is associated with the A, 2 associate B, 3 associate C, and 4 associate D. It's obvious, yes. Satisfy perfectly. So the answer is yes. This relation, professor, it is a function. Because satisfy perfectly the definition. Do you follow me? Do you follow me? Everyone follow me? I want to complicate a little bit, no? With another option, another versions. Okay, you need to apply the definition, see satisfied or no the definition. Suppose this combination, 1, A, similar to this, 2 comma b, similar to this, separated by comma, of course, comma 3 and b, b, repetition b here, and 4 and a. Okay, I don't know si es or is not function. Let me try. 1 is associated with the a. Now this arrow indicates the direction. Huh? 2 is associated with the b. 3 is associated with the b. And 4, again, is associated with the a. This is the situation using this arrow diagram of the function. No? Because I come back again to the definition. You need to understand si the answer is yes or no. What do you think? Yes or no? Nobody want to opinion? Yes. Who is that? Silvana, no? Silvana. Silvana. Oh, sorry. Let me see the chat. In the chat, dice Brian. Brian is a yes. Okay, Brian. Who? What? Another opinion. Everyone suppose que es yes or es no? Come on. What's going on? You have no opinion. You are totally confused in this moment, no? A ver. No. Dylan dice no. Definitely no. Dylan say no. Okay, so we have two opinions. Good, I like that. However, one is true, another is false. The people who believe que es a function, the answer yes or no. Come on, one by one. Opinion, like attendance. Georgia, what do you think? Yes or no? I am checking also attendance, no? So you pay attention or you don't pay attention. Laura. He said no. Clifford said no. Clifford said no. Joseph say. Daniel sí, no. Daniel no. Entonces, the majority of the students believe que no, no? No? No function. What mean hard? Daniel. Is Alexa, what do you think, Alexa? No. Silvana is no. Okay. Let me see. Guy, unfortunately, you are in big trouble. The answer is yes. I know it's confusing. Look, the definitions say, that each value of the domain is associated with the only one. Pero the opposite, the converse, no. Okay, the only restriction is, suppose one, so the only possibility que we have no function is suppose hypothetically, que one is associated with the A y es associated with the B. O sea, es two value for each value of the domain. Pero okay, es perfect legal que one is associated with the A, que es only one, and 4 is associated with the A. There are no contradiction. Okay, entonces now es la que many to one. It's okay. Why it's okay? Because the definition say only one, but only one where? In the range. So say in this part only one. Good, satisfied, good. No problema, good. This is yes. However, one too many, no good. Because totally should I understand, Professor? Thank you. No, okay, Dylan, it's okay. This is the idea. Okay, the idea is that you have too many in the range is no good. No good, no function, no good. And the answer is yes. What are the only differences? Well, let me explain after that. No. The answer is exactly the same. Yes, comma, it is a function. Repetition, the same. Entonces one more relation, suppose relation 3. And one of relation 3 is 1 comma A, again, repetition, this first guy, or the pair, 2 comma B, the second is the same, 2 comma C, and 3 comma D. The answer is a function or no? No! What is the problem? I can see que 2 is associated with the B and associated with the C. So no, it is not. Because of one too many. This is the idea. I suppose that everyone understand very well the idea. This is a little bit confusing. Okay? But okay, now we are clear. Entonces, let me summarize. What is the conclusion? What is the super fantastic conclusion? Well, the super fantastic conclusion is that when you have one-to-one relation, que es one-to-one, of course, it's okay. It's a function. When you have many-to-one, it's also okay, because the important thing in the definition of the function is this one. And si es one-to-many, no. No, okay, it's not okay. Okay? Entonces, well, I promise, now in this chapter, in the last chapter, que I want to illustrate the advantage to be one-to-one. One-to-one es function, pero es super especial. A many-to-one es a function, pero no es ordinary, no especial. And you see some property que we studied in chapter 4. No. Let's practice a little bit. Suppose que determine whether is this relation represent a function or no. Suppose que in the test I give you relation 1, relation 2. Pero I ask one more thing. I want to say si is function or no. Yes, no. And why not express a domain and express a range in both cases. Domain and range. Okay, the first relation is using this symbolic curly bracket, no? And you enclose in the parenthesis the order pair 2, 3, comma 4, 1, comma 3, negative 2, comma 2, negative 1, and close this curly bracket. Well. The second is thinking about this. The answer is yes or no. Why? And determine domain and range. Just the new thing I want to practice. Suppose 4, 3. Suppose 3, 3. And suppose 5, negative 1. Okay, the answer is yes or no. Yes or no? What do you think?
No.
Yes. No? Okay, you are right. She said no. I agree with her 100%. Let me explain the domain part. Domain I use in red color. Domain by definition is the set of X value. Or in another word, is the set of the first component. So this, and this. But without repetition. So you separate by comma, F4, and you separate by, and 2 repeated, so not necessary to copy. To express it like that, 2, 4, 3, 2. No, because the set in Mathematica have two important. There's some important property for the set. So the set is totally irrelevant, the repetition. So the set 2, 4, 3 is equivalent to say it's the same element. So the set working like a teams. sea, suppose que one thing, we have María, José, Pedro. Entonces, María, pero si es María, es María, no. Si es María, no. Entonces, we have only María, José, Pedro, and that's it, 3 guys, okay? O sea, es no necessary repeat. And all important thing in the set is that it doesn't matter equivalent to the set 3, 4, 2, because the order is totally irrelevant, it's not important. And suppose another possibility is to copy 4, 3, and 2. And any combination that you form a 3 by 3 is 6 combination in total. Now the range, one of the range is the set of the Y, que Y is the domain. So the range is set. You need to be familiar with this technical name, domain range, set of the Y value. In other words, is the second component, que es 3, a 1, a negative 2, and a negative 1. In this case, we have 3, 1. Remember, I don't care the order. The order is not important. Negative 2 and negative 1. And not necessarily any repetition. Who helped me with the second relation to? It's a function, yes or no? The second.
Yes.
Yes, she said yes. It's a function. Good, very good. Now, I agree with you 100%. And the domain is, let me see, 2, 4, 3, 5. 2, 4, 3, 5. You copy in this order or in any other order that you want. And the range, let me use a blue color to symbolize the range. There's 3, 3, 3, 3, and negative 1. Actually, not necessary to write 3, 3, 3. No. 3 only one time, negative 1. End the story. Any question? So far good? So far good? Good. It's easy, I know. Okay. That's it, no? We continue functions. Now, for example, I want to verification. So, okay. You see, one way to express the function is using the set of the order pair. Yes. But one possibility we study here is, for example, doing the graph, because the graph is exactly order pair X and Y. So now, si suppose que the idea is que you have a graph, it's given in the test. Suppose 4 graph. That's all with this is X. This is Y. And suppose one graph like that. Let's give it. This arrow indicates also that the graph continues forever in that direction. No, it's not increasing, it's continuous forever. It's like an extension. Suppose this is different, it's like that. Like that. Boom. Another graphic is like that. Boom. Another graphic is like that. It's a circle that we studied last class. Entonces the question is verify, identify. The graph, if this graph corresponding of function or no. The answer again is yes or no. Entonces now it's the same idea. However, I want to explain new idea, new test. es súper important when you have a graph and verification si ese function o no, que es called vertical line test. Vertical line test. We're using the vertical line test in any graph 1, 2, 3, 4 to verify si ese function o no, and what consists the vertical line test. Bueno, you are doing hypothetical vertical line, like that. Choose. In any point, guys, in infinity point. Suppose it's like a rain drop. Infinity vertical line. Why not here? Another. Infinity vertical line. Infinity. Here or here. If the graph, the vertical line, cross, our graph gets given, the curve gets given, in only one point, it's a function. Yes. Why? Because 1x gets this x. Corresponding only one y. However, in this case, no. Why no? Because this x, so the vertical line touch 2 point, yeah, it's no function, yes. 2 or 3, more than 1. So, si it's only 1, no, in this case, this x corresponds this y, and this y, 2y. How you visualize this idea? Well, you visualize 1x corresponds to y. Look at that. y1 and y2. Dilo. Entonces es obvio que es one too many. No good. In this case, no, it's easy. It's only one. Look, pair, vertical line, yes. Or here, yes. And here, no. No, because we have 2 points. No. It's clear. It's clear, right? It's super clear. Any question, guys? Do you understand very well vertical line test? Okay, this is in the case in Alex. Okay, the graph is given. Understood. It's in the case in Alex, maybe in the Alex online homework and online test. Okay, some graph is given, and you need to determine si es function or no. You looking only that, and you draw hypothetical vertical line. See in at least one point of the x cross touch 2 points in the y, no function. Okay, vertical line test. Let's move on to the same identify the function again, but another way. Identify the functions. But in this case, by the equation. The one equation is given, and you need to determine can touch 2 points on the y. Yeah. So I can't not touch 2 points in the y. Es illegal to be function, no? Si touch 2 points, entonces no es relation. Okay. Yeah. Brian, it's okay. What is the problem? Okay, stop. The problem is that one equation is given. Okay, understand. And you need to identify si it's a function or not. This is the idea. But the problem is that there are two different possibilities to express the equation. One is called explicit. This is a classical mathematics guy. Explicit form. Remember, this is called algebra, but I guarantee you see this in pre-calculo, you see this in calculo. The student can need to take that, no? Implicit is when the y is totally isolated. Entonces, explicit, es the word que indica que es easy, understandable, clear, no confusing, explicit. When it's something explicit, es que es clear. Let's suppose que es y igual minus 3x plus 5. This is explicit. Another example is y equal x squared minus 6. Another example is y equal 4 divided by x. This is example of the explicit form of the equation because the y is totally isolated. In this case, isolated in the left-hand side. Nice. Implicit, when something is implicit, it's because the thing is not clear, it's confusing. Professor, you explain implicit, you explain not clear. I don't understand your explanation. Because I explain something, but I don't go directly to the point. I blah, 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 too much blah, 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 but I don't go directly. It's implicit, not clear. So implicit is when the y is not isolated. For example, this equation is 3x plus y equals 5. By the way, it's equivalent to this. But in this case, nobody is isolated. It's isolated 5, but 5 is not variable. In this case, for example, suppose that we have x squared minus y equals 6. It's equivalent, it's the same thing, identical. But change professor and here of you2 attendance. Okay, don't worry because for the attendance, you don't worry. I check it in the first minute of the attendance. However, I check it in the last moment because you go inside the lecture, your number is recorded in Skype. In the background of the Skype, I see your name, I check it, double checking the attendance. In this case, x times y equals 4. So the thing I try to explain is that there are two possibilities to offer equation in algebra, no? Bueno, okay, I need to analyze this equation or no, it's a function or no. Okay, but okay, the first thing you should do is to put clear. And clear is explicit. Clear is explicit. Okay, let me explain something. Suppose this equation. Example 1 of the determine using the equation, see a function or no. Suppose this equation is y equal x squared plus 4. Oh, it's explicit. It's explicit because y is isolated. Okay, to say now it's clear, equivalent to say clear. Understandable. Why is understandable? Because I can see that one value of the x, que you assume arbitrary, 3, negative 3, 4, generate only one value of the y, que es x squared plus 4. Okay, in this case, well, in this case, maybe negative x generate exactly the same value because negative x squared plus 4 is equal x squared plus 4. It's exactly the same y value, no? But it's okay, it's many to 1. Entonces, it's a function. Okay? And this case was easy because the equation is given in explicit form. But sometimes no, sometimes it's confusing. Suppose this example. Example 2. In the example 2, you have, for example, let me see this. X is equal y squared. It's already in explicit? No, it's implicit. Why is implicit? Because y is not isolated. Okay, entonces no clear, unclear. We can analyze in that way? No. You need to express it in explicit. So, well, I don't know, but for solving the y alone, you apply square root both sides. Because my goal is to eliminate this power 2. Entonces y, because power 2 and square root cancel out each other, is y, you know that. But in the right hand side, we have two values, plus and minus. Therefore, it's not function, unfortunately, because one value of the x generate two values of the y. One positive radical x and one negative radical x. So no function. No function. Okay, another example. Do you understand this or no? Okay. By the way, see, I put it, for example, you be smart. See, you are doing the graph. I know that you are not too familiar with the graph, but okay. Look, this is the original equation that's given. However, see, we using Desmos, and you put this equation, and Desmos give me one graph like that. 1, 2, 3, 4. It's a parabola. 4. And when you apply the famous vertical line test, this curve passed the test or failed the test? What do you think? Pass or fail? This one. This one is this equation. Pass. So we get the same conclusion, no? Here we get the same conclusion. Super. However, when they put this guy in Desmos, the graph gets given look like that. It's a parabola, but it's another kind of parabola. And when you apply the vertical line test, pass or fail?
Fail.
Exactly. One more example, the last one. So it's when you have equation, and you need to determine if it's a function or no. Be careful, because the first thing you should do is express the equation in explicit form. Explicit means y totally isolated. Suppose this. Absolute value y is equal x plus 1. Okay, this is again implicit, because to be explicit, we need y alone, totally isolated. You have absolute value. So I know the rule of the absolute value, okay, is you remove the bar and you put this expression or this expression, okay, minus, no? By the way, so you apply distributive property is minus x minus 1. So what's going on? Okay, we have, for example, here, so you isolate the x, is y minus 1 equal x. Now, so you isolate the x here, I move the x, I move the y, x is equal minus y minus 1. And the thing I did was I moved minus x to the left, like a positive, and y I moved to the right. So now I can see 1x in this equation determining two different y. One is y minus 1, and another is minus y minus 1. It's obvious que no function, for the same reason. Okay? Okay, entonces conclusion, si one equation is given and you need to investigate si it's a function or no, the first step that you should do is express it in explicit. Okay, explicit is clear. After, the rest is easy. Okay, now let's go to the function notation. Function notation is extremely important. Function notation is extremely important. Function notation. Extremely important. It's a fantastic notation. They help me to understand the function part. Okay, the chapter 2. Chapter 2 is a function and their graph. So now, what is the function notation? Well, the function notation is, instead of y, you put f of x. Okay, by the way, this quantity is equivalent. It's the same thing, but this is more clear to see something. Okay, I want to explain now. Suppose one elementary example. No complicated. I bring one easy. Suppose okay, one equation is y equal 4 minus x squared. But I want to manipulate with this function. I using function notation. So I replace, no y anymore, I put f of x. Okay. And this notation allow me, for example, evaluate in any point. Suppose evaluate in 3. What should I do? Well, you replace x for 3. So 4 minus 3 squared. 4 minus 9 is negative 5. Okay, fantastic. You plug it in. It's important to say something. These parentheses do not indicate multiplication. No, no, no. This represents the argument of the function. Entonces, profesor, pero what is the argument? You never explain argument. Bueno, argument es domain, element. Element belong to domain. O sea, domain is a set, pero any element inside I want to call argument. The argument you transfer to this. And this is just plugging in. So you replace x for the value you want to plug it in, and that's it. But okay, that's it. No. We can do fantastic thing. For example, you have the function, the original function, this one again, but I want to apply transformation. Okay, I want to study next class in detail. Suppose I do it, this is like a translation. I move, I don't know if it's horizontal, vertical. We study this in detail next class. Okay, the thing I want to understand is that you replace x for x plus 3. So this is one part is a variable, another part is numerical, no? So 4 minus parentheses x plus 3 squared, something like that. Okay, that's it. No. Let me try to manipulate this algebra. This is 4 minus bracket. I put a bracket too because I want to FOIL that, guys. And this is x squared. This is plus 3x. This is plus 3x again. And this is 9. And we combine like term, x squared plus 6x plus 9. And this is an expression inside that bracket. So 4 minus, and this might affect everything. X squared minus 6x minus 9. Okay, what's the final answer then, professor? It's minus x squared minus 6x minus 5. This is the expression que corresponde this function notation. X plus 3, que in this case is translation. So we move somehow our graph, our function, I don't know exactly in what direction. This is the problem for the next class. Okay, this is translation. Okay, and that's it. No. We're doing some more transformation. We're doing reflection. What is reflection, professor? No, reflection is when you replace x for negative x. So instead of the original f of x, because I forgot to say, okay, you read that like f of x. Okay, so this is f of pero minus x. So when you replace x for minus x, you are doing reflection like a one mirror, and you flip it something. How? I want to explain next class, not today. But let's do it. Entonces now the original is 4, and you replace x for negative x like that. Oh, but I know que negative x squared positive, and stay alive. This negative is this. So you compare this equation and this equation, they're the same. So nothing happened. I make a reflection, however, doesn't happen. This situation, this happened in the even function. Even functions. Let me try to anticipate something. So the function that you make a reflection and nothing happened is called even. The graph of this function, the original function that we are studying now in this section, is this function. Let me try to do my best. Suppose I put in decimals, but not necessarily decimals because it's too easy. The graph look like that. And y-axis is 4. 1, 2, 3, 4. That point is the point 0,4, que represent the y in a set, and the x in a set is positive 2 and negative 2. I want to prove it after that. Positive 2 and negative 2. So my graph is a parabola also, but up and down. Open like that. Open like that. Entonces, si you make a reflection, but this reflection is about the y-axis. When you replace x for negative x, the thing that we are doing is reflection. So this is complete symmetry with respect to the y-axis. And when you make a reflection, it stays the same. Nothing happened. That part, now it's that part. And that part, now it's that part. That is the reason que the expression stay the same. And this happens only in the even functions. We study after in another lecture in detail even function, odd function, and neither function. But not yet. Okay, another possibility is to make like a stretch or compression of the graph. And I suppose that you multiply by 2, by 3, by 4, but multiply, suppose you multiply inside the argument. Multiply by 2. This is, I suppose that this is a stretch because multiplication by 2. Okay. I have no idea what is the geometric effect. This is not important now. Important is that you take the original equation, the 4 minus parentheses, and you replace x for 2x. And leave it like that? No, of course, no. If you square this, is 4 minus 4x squared. Done. This is the answer when you perform that transformation. Now we can use in the function notation in the next lecture when you study any detailed transformation of the function. But it is the only application? No. There are another fantastic application. It is when you need to find the y in a set, and when you need to find the x in a set of the any function, of the any graph. Entonces, I remember the mnemonic dy. Dice, professor, what is the formula to find the y in a set? The formula is this, f evaluation 0. And what is the formula for the x in a set? The formula is f of x equal to 0. Now you declare, for finding the y in a set, you declare x equals 0. Actually. Okay, proving in here 0. And when you want to find the x in a set, you declare y 0. Many ways to memorize. This way or that way. I prefer that way, the function notation, because it's more mnemonic to remember. Suppose. Let's go to the previous example. Suppose the f of x is equal 4 minus x squared. I need to find both. I need to find x in a set and y in a set. Well, okay, let's do it. You evaluate 0. 4 minus 0 squared. 0 squared is 0, 4 minus 0 is 4. Therefore, the y in a set is located at the point 0,4. Because the assumption was x is 0. And the y corresponded with this 0 4. Okay, and now ready to plot the point. I did before, but I want to do it again. Look, this is my graph. Off. Okay, 4. 1, 2, 3, and 4. That point is the point 0,4. Let's do it now. X in a set. X in a set is different. It's f of x equal to 0. F of x equal to 0. It's like, who is f of x? Well, f of x is 4 minus x squared equal to 0. And you have, in this moment, one quadratic equation. Okay, we are solving using a square root because it's easier in this algorithm or method because b is missing. To say you, for example, move x squared to the right hand side, you apply square root both sides. We continue here, and this is x alone, and it's a plus or minus 2. Oh, so we discovered two x in a set at the point 2, 0 and negative 2, 0. They plot that 1, 2, 1, 2. This point is the point 2, 0. This point is minus 2, 0, and our graph look like that. Esa parábola. La parábola que open down. Okay, super. It's another application of the function notation. Find the intercept. We use it. I promise that we using every day. Find that formula. Let's doing another example of the y in a set. Suppose the function is given. Let me change the name because we're using any name for the function, no? G of x. The typical letter that we use in college algebra, in mathematics in general, SF, SG, SH, SR, FP, but in general we can use in one letter, arbitrary, 2 letter, or 3, no more than 3. For example, I promise in the chapter 4 we study one function that's called LM of x. Another function is log of a 3 letter. The 3 letter is the name of the function. The name is g of x. And this is absolute value. You are very familiar with the absolute value function. And my goal is find y in a set and x in a set. One more time. And try to do roughly sketch without decimals of the graph. Well, now remember the mnemonic device to remember the formula is g evaluating 0. You plug in 0 plus a is a, y absolute value a is a. Now the point is the point 0, a. This is the y in a set. The x in a set is different. Is g of x equal to 0. Now who is g of x? In our example is x plus a equal to 0. Wow! And you solve this equation, but I know very well. Solve this equation. The professor explained very well the equation that contains actual value. He say that when the right hand side is 0, we have only one equation. And you obtain the solution when you remove the bar, no consideration, only one possibility, no 2, equal to 0, then the answer is negative 8. Entonces the point is negative 8, the x in a set is negative 8, 0. With these 2 points, we can obtain more, but this is super important, interesting point. We can do the graph, roughly sketch. XY. 1, 2, 3, 4, 5, 6, 7, and a. This is a point 0, a, this guy, and negative a. 1, 2, 3, 4, 5, 6, 7, and negative a, 0. I anticipate that the absolute value function look like a 1b always like that. And our b is passing through that point, and continue in that direction. But at least we get 2 points, important point. This point gets a corner and another point. Another point is symmetric. Okay, in my opinion is 16, I guess so, no? Or negative 16. Here. Because when you plug it in the equation, negative 16, g evaluated negative 16, let me see what happened. Absolute value negative 16 plus 8 is negative 8. The absolute value negative 8 is positive 8. And that point is the point negative 16, positive 8, exactly the same symmetric. Negative 16, 8. Everyone follow me? Everyone follow me? Okay. So let's practice now in this topic of the function notation, the typical example that you can see in the test. Okay. In the test, I don't know why, I don't do the test. The test is doing by the mathematical department of the campus. This question is classical in the test number 2. Is find one thing, let's call it difference quotient. Entonces, what mean that? Well, this is like a one formula que help me to find the if the function is increasing or decreasing. It's like a slope, but actually it's not slow. It's more than slow, more sophisticated. What is the formula? The formula is different quotient is equal. The function is given x plus h is totally arbitrary number minus f and x divided by h. It's the formula. Entonces, what is the idea for the question of the test? Well, one function is given. Suppose this, quadratic. And the question say, compute the different quotient for that function. Compute the different quotient for that function. And let's do it. Let's do it step by step. Step one is compute that part of the formula. Let's do it. It's f x plus h. Why don't you replace x and the original function for x plus h? Okay. And that's it, no? No. I need to manipulate algebraically. You FOIL this. It's a multiplication to binomial. And this is easy because it's distributive property. But let's do it one by one. This is x squared plus x times h plus h times k. I put it in the same order. And h squared. And we continue. Minus 5x. Get the distributive property here. Minus 5h plus 6. Okay. I finish the step 1, que es this part. This part, que is the red part. Que I want to highlight in yellow color. Let's move on to the second step. Step 2. Step 2 is easy. Step 2 is computing the top part, is f of x plus h minus f of x. What is that? That part. The blue part. This and this together. Of course, I'm using the expression and que I highlight in yellow color, que I copied before, que is this, no? Yeah, rewrite again. Look at that. This guy is this guy. I rewrite. Entonces, x squared plus xh. Well, actually, sorry. I combine letters to xh because they are lighter. There are no reason to write separately. No, this is a stupid thing. Let me erase that part. Well, no erase. I put 2 here in the front, twice. Plus h minus 5x minus 5h. We cannot combine here because there's no light term. Plus 6. Subtracting the original. And the original is this one. No. This is the last step, Dylan. The last step is divided by h. Now you're subtracting. You're subtracting now, Dylan, that part. Pagada. And that part is this. And subtracting polynomial is super easy. Because the only thing you should do is change the sign. It's now negative, positive, and negative. And in this moment, wow, a lot of people is canceled. A lot of people is canceled. Let me show you who is canceled. It's cancel this. It's cancel this. It's cancel this. And stay alive. 2xh plus h minus 5, no? Wait. I make a mistake. Yeah, I make a mistake here. Look, this is h squared. H times h is h squared. I suppose I forgot something. Minus 5. You see my mistake? When you apply FOIL, h times h is h squared. I forgot that one. I put only one h. No good. And those are the final step. Dylan is divided by h. Okay, super easy. Divided by h. Look at the formula. In the formula, the last thing is divided by h here. It's doing, but this is easy because you divide this expression, okay, I get in the second step, and you divide by h. If you divide by h, you can divide one by one because it's polynomial divided by monomial. So this h is cancelled, this h is cancelled, and this h is cancelled. 1 and 1 of these. Stay 2x plus h minus 5. And this is the final answer. Different question. DQ. Well, you say, well, professor, okay, I understand, but what is the interpretation? Well, the interpretation is similar to the slope. So you have a curve, for example. You have a curve. This is x, this is y. This is the function f of x. And you pick one point arbitrarily, okay, called x. And you increasing a little bit. This is x plus h. That distance is h. And you determine that y value is f of x. And you determine this y value is f of x plus h. Entonces now it's very, very similar of the formula of the slope of the line. But in this case, what line is? It's no line, professor. It's a curve. Well, okay, but we have a secant line connecting this point and this point. Okay, this is a line connecting this point and this point is called secant. Secant because connecting 2 points. Si estañe connecting one point. Entonces, and the formula for the slope is y2 minus y1 over x2 minus x1. This is the formula. But in this case, every reduced set is similar because the y in function notation is f of x plus h minus f of x. Can you explain the beginning of the step 1? Yeah, of course. Divided by, and the difference between x2 and x1 is h. And it's the formula. So what is the geometric interpretation? Well, it's a quantity. Okay, give me, for example, I don't know, when you compare this, it's a number, ch, I suppose is 1, and x is 2. You plug it in here, give me one number. See, this number is positive. That means that the function increasing, go up. Si es negative, the function go down, decreasing. You want to compare two functions, you determine the different quotient, and you see what the different quotient gets bigger, and this is the function increasing faster. That's it. That's the idea. It's the one idea increasing. You say step 1 can explain. Okay, step 1 is easy. Look at that. Step 1 is you replace in the function notation this, but you introduce instead of x, you put x plus h. That part you understand or not? Who is the student that asked me that question? The step 1.
Me.
Okay, who is me? Name?
Claire.
Claire, okay. Do you understand that part? Good?
Yeah.
Okay, now algebra. You take that and you FOIL. Because actually the thing we are doing is the multiplication to binomial. I did that. X times x squared. X times h, this is plus, sorry. Plus xh, again repetition, the same guy. And this is the part I confusing, it's h squared. I did this part. Now the second part is minus 5x minus 5h. The last part, plus 6. Done. You understand step 1? Got it. Okay. Okay. Entonces, I suppose que you need another example. Yes or no? Or no? So you understand very well this part. Let's do it. Let's do it. Let's do it. Let's do it. Did I say you understand? Do you believe that we need another? Don't worry. In the review package, as always, I am doing. I go to the beginning, no? I reinforcing the topic is important, no? In our test, no? Okay. Just let me try to do one more. That's it. Let's do it one more. For clarification. Dylan say. Okay. So one easy, Dylan, no complicated. Okay, suppose the function is a linear function. F of x equal 3x plus 4. This is a line, no? It's a linear. Si es square, no, es parábola, pero no, it's no square, es linear. Entonces, the different quotient, using my intuition, because the professor explained a different quotient is similar to the slope. 3 gets slow, no? 3 is the slope of this line. Remember, mx plus b. This is intuition. Intuition. Let me prove mathematically that this is true. This intuition is good. Okay. Step by step. I compute f in x plus h. 3 times x plus h plus 4. Oh, it's easy because we have only one binomial. You apply distributive property, and you have 3x plus 3h plus 4. Done. Now subtraction. This minus the original is 3x plus 3h plus 4 minus, opposite sign this, minus 3x minus 4. I can see now, this guy is cancelled. Always happen in this step. A lot of people cancel and stay alive only 3h. Divided by 3. Divided by 3, no, by h, sorry. It's obvious that 3 exactly we expect. In this case, the different quotient is perfect coincidence with the slope. Because this is a line. Si es el corno. Si es el corno, you have 2 points. You have different quotient is the slope of this line, the second line. Okay, depending on the point, no is constant. So you select another point, for example, this and this, we have another second line, and the slope is no exact. It's no constant. Okay? Okay? Let's do it now. We have only 5 minutes to explain. One no big deal, easy way, easy C. Important in the test 2. Important in the test 2. Do you feel strong at the different quotient? Probably. Feel strong or feeling weak? All right. Opinion. Yes, sir. Strong. You, Dylan, pero I want to know the rest of the students, no? A ver. Junior bracket. Are you feel okay with Junior? You are good?
Yes.
Junior, do you see the extension guy I created for you?
Yes.
Okay. Take advantage of this opportunity.
Okay.
Okay, now, let's do it now. Different situation, different problem. Case, for example, I give you, in the test you can see one example like that. Suppose that one graph is given. This is given. Suppose that the graph look like that. Let me use in that color. Okay, I like that color. Okay. And okay. Remember, this arrow indicates us that this continues forever. But in this case, we have a hole. In this case, no. We have something like that. And we have something like that. Entonces, you need to understand que in one graph, when you have in one graph something like that, it's because this point is defined. Entonces, now, what is the reason that you put the circle full? Well, because I want to emphasize that this is defined. However, when you have this, it's undefined. Undefined means that the function do not exist in this point. Suppose that this point is 2, and suppose that this point is 3, and suppose that this point is 2, and suppose that this point is 2.5. And by coincidence, this is the same, and this point is 4. Suppose hypothetical. The one graph is given, and the graph include something confusing part. What is the confusing part? Some hole. This is a holes. This is a holes. And this is the gap. The gap. And the gap we have no function. We are discontinued. The function is broken. Okay. And the question say compute domain. Or find, not compute, domain. Find the domain. And why not the range? Only look in the graph. No mathematics, only look in the graph. Using your eyes. So let me again repetition. What is the definition for the domain? Well, domain is a set of the x value such that the function is defined. See, it's undefined, like this hole, is completely out of the domain. No, don't belong to the domain. Entonces, let me try to understand domain. I propose you, let me erase that part because range is after. Let me propose you, for example, projection our curve onto the x-axis because the x-axis is the x value I need to find for the domain. When you pick point arbitrary, boom, 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 and you project it, you can see it's something like that. Look, this is continue forever in that direction because this continue forever. And you project it. Projecting means that you projecting here at that point onto this, and we have one projection. Onto here, stop here. Because I discovered that we have a hole here. And the hole is do not include in the domain. This continue here, continue. I highlight that part, and 3 is no hole, it's defined, so it's bracket. It's bracket. Here we have a gap. We have no function in 3.1, 3.2, 3.5, 3.7, no. And now bracket again, here, and continue forever in that direction. Conclusion, our domain is an interval notation from negative infinity, que es this guy, look, comma, to parenthesis, I try to represent this part, union 2, 3, bracket, and union 4, infinity. This is the domain. Do you understand this or no? Confusing, very confusing.
A little bit.
Little bit. Okay. You projecting the purple color curve onto the x-axis. And the projection I can see is the yellow projection. What is the difference? We have bracket and parentheses. When you have parentheses, it's not included. It's because corresponding with the holes in 2 dimensions. In 1 dimension, it's a parenthesis. Okay? However, let me using another color, maybe green color. And the range, que by definition is the same, but it's the y value, not the x value. You're projecting the that curve, any point, but you project it on the y-axis. And I can see the projection is coming from negative infinity. Look, because when you project, for example, that point, is this point, and this I say can continue forever. This is going to the down, negative infinity here. Okay, here. We have and two half, or we have no, and two half. Why no? Why half? Because here no value on the, but this is a coincidence. This circle is defined overlap this case hole, and together give me like a define. Entonces I indicate this. Bueno, this is a continuation, no? It's a continuation to 2.5. And 2.5 stop. Include 2.5, of course, include 2.5. And the way to represent is bracket. I put a bracket like that, no? Because it's a bracket, but this is vertical bracket, no? Entonces the range is from negative infinity, comma 2.5. Okay, that's it, guys. That's it for today. Too much. Thank you so much for your attention. Okay, so now remember, I suppose that everyone is doing now Alex homework, homework 3, homework 4. Remember, it was very, very useful.